So folks, hey there, it's Modern Retro Tech. Today we are doing a stream in Elixir. It was a bit unexpected for me. I actually planned to do another stream with Rust, but Jose Valim recently released a new library called Nx, Numerical Elixir, and today I want to take a look at that. I'm very fascinated about that for a number of reasons. One of them is the fact that, I nowadays converted to become a data team lead, and soonish I will start also doing some more data science stuff, I hope, and machine learning. So looking at all the options available is kinda relevant to my job, but apart from that, it's also something that I have been interested in for some time. I first learned about machine learning when I was still in uni. So it was, I think, my second year in uni or something like that. And I was just watching videos from Andrew and Ge. Coursera was just launched, and it was very fascinating new thing. It was one of those things where you're kind of surprised by what computers can actually do. So I was very much into that, but at the same time, I was introduced to functional programming and distributed stuff. And my first job was Erlang and distributed systems. So over time, I kind of drifted away from that. I haven't looked much at machine learning before. But then, since I was working with big amounts of data and doing apps for companies that mostly were doing some kind of analytics, it kind of became relevant again. So now, seeing my favorite language gaining these abilities, something that I never expected to happen, is very, very exciting. And I really want to see how it works. One thing that I plan to do today is to just compile the examples they have of classifying those digits and trying to make a bit of sense of it, how it works, maybe looking at the code, and also doing it on AWS because I'm a Mac user, and sadly, one thing that is not so good about Macs is GPU. And it seems to me that if you really want to experience what this library has to offer, we need to compile it for GPU. So we will give Amazon some money and hopefully gain some knowledge in return. Without further ado, let's look at the library and look at what we can do with that. So this is the official announcement from Jose about the library. I will make it a bit bigger and let's just go through that together. So he was working with Sean Moriarty together to create this library. Nx is a multi-dimensional tensors library for Elixir with multi-stage compilation to the CPU GPU. Let's see an example. And here he shows how to create a tensor. So tensor is just a multi-dimensional array. In this case, it's two-dimensional, so it's a matrix. As you can see, tensors have a type and a shape. In this case, it's signed integers S64. I was a bit surprised about this notation because I'm not sure why they didn't use I64, which is a bit more common. But okay, and the shape, 2 by 2. Tensor operations are also done with the Nx module to implement the softmax function. So this is like matrix sum in this case, and exponentiation, I believe. So yeah, there is a bunch of scary looking math. We won't be doing much scary looking math today, but yeah, I think I need to make my audio a bit quieter. Yeah, I think it's better. Okay, but we will be using a lot of math written by other people, which is always funnier to do. Here, he creates a tensor. He applies exponential function on each element here again, and he sums all elements, and then he divides this exponent version by this sum of exponents. Okay. The high-level features in Nx are typed multidimensional tensors, where the tensors can be unsigned integers, signed integers, floats, and brain floats. So no strings, no complex data types so far. Named tensors, allowing developers to give names to each dimension, leading to more readable and less error-prone code bases. That's actually something I have not seen before. Tensors considered harmful. I guess it's just like instead of having integers to index stuff, you have like names, like in Pandas data frame, for example. So privacy broadcast. So is it just assign name to things? Hide width channels. Okay, interesting, but not very relevant for us yet. Automatic differentiation. So that is the cool thing, right? That's a cool application of metaprogramming, and it is quite natural that Elixir gains those capabilities eventually, because it has those building blocks to do that, macros especially. But at the same time, it's something that I absolutely did not expect. I also really wonder how it actually integrates with this native code it generates when you compile code with Nx. We'll look at it a bit later. The graph function provides reverse mode differentiation, useful for simulations, training probabilistic models, etc. Tensor's backend, which enables the main Nx API to be used to manipulate binary tensors, GPU-backed tensors, sparse matrices, and more. So essentially, you can define multiple options for what it will compile the code to. And then, yeah, it can run on GPU, it can run on CPU. You can also use special optimizations for sparse matrices. Makes sense. Numerical definitions, known as def-n, provide multi-stage compilation of tensor operations to multiple targets, such as highly specialized CPU code or the GPU. The compilation can happen either ahead of time or just in time with a compiler of your choice. For Python developers, Nx currently takes its main inspirations from NumPy and JAX, but packaged into a single unified library. So they were focusing on underlying abstractions. For example, Nx implements dense tensors out of the box. They also wanted the same high-level API to be valid for sparse tensors. You should also be able to use all functions in the Nx model with tensors that are backed by Elixir binaries and with tensors that are stored directly in the GPU. By ensuring the underlying tensor backend is ultimately replaceable, we can build an ecosystem of libraries on top of Nx, allowing users to experiment with different backends, hardware, and approaches to run their software on. So, that all sounds really, really good. Of course, one big question is how do you, once you have tensors, it's only the first step. Having tensors, automatic differentiation allows you to define neural networks quite easily already. But you are still missing a lot of other things. So I/O, all the different formats that are typically used in data science, for example, Parquet or Feather or stuff like that. Then charting and making some visualizations. It's also something that is not yet so common in Elixir ecosystem. I think with this library, if people will actually use it, we may just see that all those tools will start appearing in Elixir ecosystem, because before there was no much use for that. Like if you create a plotting library in Elixir without it having proper capabilities for working with multidimensional arrays, nobody will be plotting anything there to begin with. Or if they will be plotting that, it will be some very artificial, very small data set stuff, because large data sets will be too slow. So in the end, it will not be used by many people, and then it kind of is useless. There is already Elixir integration in Jupyter, which is super important if there is a desire to attract data scientists to work with that. I think it will be very hard to compete with Python ecosystem, to be honest. And it will be an uphill battle, but at the same time, I feel that Nx may be very useful for people who have an app written in Elixir and want to integrate a smaller feature based on machine learning. For example, some very basic recommendation system. Before that, they needed to switch to another language. They either needed to make a component in something like Python, or they needed to use Rustler to integrate Rust. So for example, in apps that I developed with Elixir that needed to process large CSVs, we used Rust to do the parsing, and we used Rust to pretty much integrate with other formats. And this is because Elixir was just too slow. It was not good for CPU-intensive tasks. And right now, I think two things are happening, right? There is this library Nx, and there is also another thing. Erlang recently got JIT compiler. And just-in-time compilation is super important for people to be able to write something that is more or less, like maybe not super performance critical stuff, but stuff that requires decent speed, like processing larger strings, processing larger images, larger files, etc. This stuff without JIT is usually just not doable. It's too slow. And now Erlang having this capability and Elixir by extension having this capability and Nx being there and Rustler being there, performance just kind of stops mattering. It's no longer a limiting factor, at least. It's very similar to what has happened with Python, because in case of Python, the language is even slower than Elixir. But since you have NumPy, and since NumPy provides you fast multi-dimensional arrays, the whole ecosystem grew on top of that, and now Python is the main language for doing data science. Will Elixir become main language for doing data science? I really hope so, but I wouldn't put my bet on it just yet. However, smaller features in larger apps written in Elixir totally see it happening. Doing some basic data analysis with Elixir, also why not? And I think it will be an amazing boost for the language and for ecosystem, because now Elixir becomes more and more general purpose, which is pretty cool. But let's look back a bit at Nx. One of the most important features in Nx is the numerical definition called def(n). Numerical definitions are a subset of Elixir tailored for numerical computing. Here's the softmax formula above, now written with def(n). So they pretty much do the same thing. The first difference we see with def(n) is that Elixir's built-in operators have been augmented to also work with tensors. Effectively, def(n) replaces Elixir kernel with Nx def(n) kernel. Oh, really? However, def(n) goes even farther. When using def(n), Nx builds a computation with all of your tensor operations. Let's inspect it. So actually, since we are using that, let's also do that. I already have installed it. One thing of warning. So first off, you will need to have Bazel to work with this stuff. I tried to install Bazel with Homebrew. By itself, it didn't work so well. So what I suggest, you can install Basilisk. It's like a version switcher kind of thing for Bazel. And Bazel is this compiler builder tool from Google. I have never worked with it before. So for me, all of this is kind of like dark magic. I don't understand really what's happening there. But in essence, you can then specify the versions they need with this Bazel version thing, and then it kind of works. So you then can compile stuff. So I tried, before I understood that ROCM, AMD's CUDA kind of like thing, it doesn't really work on macOS at all. I tried to compile with that. It was failing, saying this client is not configured. And I was like, okay, what the hell is happening? But you can just run it like that. It will compile stuff on CPU. Compiling stuff on CPU is already pretty cool because we can kind of make a comparison, right? So here, let's simplify it a bit. I will just take ones here and I will make a 100 by 100 by 100 three-dimensional matrix, three-dimensional tensor, whatever. So in general, we have like 1 million elements here. So we can create a tensor with this Nx broadcasting, or we can create a normal list of lists in Elixir, which probably not be a good idea. But in any case, I will recompile it and I will import Nx test. And I will do the test tensor thing and I will call it, so I should just call it T. So you see that it works very, very quickly. I really wonder if we will try to do, and you can see that I also said that it should use Xla as default compiler. So that's the thing that makes it fast, actually. Now, if I try to do test tensor, I don't know, beam, I guess. How do we do that, actually? So this is like a list. I don't know. I guess I have not written Elixir now for almost 3 or 4 months. I don't, it's like, what am I doing? I'm almost doing ranges. They were written like that. Yes, okay. And the syntax here is, and then for J, and then for K. This is very ugly, but what can you do? Oh, actually, why I'm even doing that? Because I think I can convert it to list with enum to list. Yes. So this thing already should generate me like two-dimensional thing. Yeah, it does. And this thing should generate three-dimensional thing, right? So I don't actually need indices here. Now, if I recompile that, and let's just do the whole timer TC thing and just call this function. So Nx test tensor bm. We don't have any arguments. We will get time and we get tensor, well, not tensor, just the array of arrays, list of lists, more precisely here. Oh yeah, of course, this should be an atom. I actually forgot, is there a way to prevent it from trying to print it? Because then the printing itself will be a tad problematic. Oh, come on, stop. Okay. So that is like how long it takes to execute it. I won't repeat the same mistake again. I will just do the compilation here. But actually, maybe we can do that and try to see if... No, it still prints it. Okay. In any case, it takes like 145 milliseconds to create this million of elements thing. Actually, okay, it was not completely honest comparison either, because do we have something like fill or duplicate? Or I think it was in list. Duplicate, yes, with duplicate and positive. So instead, I actually should have written this. Let's duplicate 100 times. And let's just check. Yes, okay. So, okay, let's try the magical thing again. I will just stop it immediately after invoking it. I actually didn't even need that. And let's write this in here. Nx test tensor beam. No arguments. Time. Like that. Right? So now it's a bit faster. It's like this. Because it doesn't need to generate everything from 1 to 100. But printing is super slow, of course. Okay. Now let's try to do it with this Nx stuff. So we have this function broadcast. I was a bit confused because I'm used to broadcast in Julia, where it takes a function and applies it to each element of an array, or like along certain accesses in an array. Here broadcast is like fill. You essentially take this element and then you create an array where it is repeated with the specified number of dimensions, specified amount of times. So it will be the same thing. It will be array with 100 arrays, with each of element of those is like array of 100 once repeated. But let's see what the performance will be like. So I will also do timer TC here with this notation because it's faster. And well, I actually don't need to import yet, but this is also all right. And I will also say time, and here I will call it t. And you can see that it is way faster. Another thing, it knows that it shouldn't print this stuff. So this stuff is working on CPU right now. We still will need to do the Amazon stuff a bit later, but still also let's look quickly at how we can do summing. So when you write this defn, it essentially compiles it, depending on which kind of client you have installed, like depending on how you work with that. It can compile either to CPU or GPU. Here it compiles to CPU code using this compiler from Google called XLA, which is like optimized compiler for machine learning. That also does some optimization for fusing operations together, apart from just compiling it. So if we now try to do the same thing, let's call this res, and let's, instead of test tensor, let's do direct sum. So direct sum is just called this function in next sum that takes the tensor and returns the sum of all the elements. So nothing super fancy there. And ooh, didn't it find it? Oh, of course, because I'm not passing the tensor itself. So now you can see that first it initialized for the platform host. This does not guarantee that XLA will be used devices. And it shows this. I would imagine that means that it just works on my processor, on my CPU, but I have no clue. And at first it's actually slower. But if we call it again, you can see that it's way faster. So that's kind of because it's a JIT, essentially. It is typically about 1 millisecond or even below 1 millisecond here. And I think it's quite impressive. I also would imagine that the expenditure of operating memory is way less for that. Now, another cool thing about this is that you can also do reduce. So here I'm just reducing using the same tensor theme, starting with 0 and just adding manually. So that kind of allows you to pass like any functions there, right? I think. At least that's what I think. I'm not sure. I think there are, like, if you call just like some Elixir random function, it may not work, but we will need to see. So then I can take this and just duplicate this thing and just go here and to reduce sum, and again you see we get this JIT behavior that it precompiles it, and then suddenly it's fast. I think this is pretty cool. Of course, cooler thing is if we work with floats. Also note that the type was inferred as signed integer. If I now do recompile, and I import and I rebuild this, and now I'm repeating 1.5 here. I can then do the direct sum, and it is about the same kind of speed, right? It's a tad slower because, of course, those are floats, and floats are a tad more expensive, but otherwise, it's still very fast. Now, knowing that it works on the local processor, let's try to also make it work on GPU, actually. Do we want to go farther through the post? Let's quickly go through the rest of the post here, and then we will try to run this stuff on GPU on Amazon. So, however, Defn goes even further. When using Defn, Nx builds a computation with all of your tensor operations. Let's inspect it. So we can actually do that, right? We can just inspect it. Why not? Ooh, that looks fancy. So, so that's how it looks inside. You get this Nx tensor, it infers the type, and then it represents this expression. So it has parameter a, I guess this is our t. It does exponentiation of that, twice actually, interesting. And then it sums it. So this is like d is this expression, b is this expression, and then it divides b by d. So makes sense. It didn't, like, I don't think it fused anything together yet, right? But it is, it did compute something. Looks like a very small number. At least it's the same small number, so we know that it is stable. now when invoked, you will see this printed. Yeah, this computation graph can also be transformed programmatically. The transformation is precisely how we implement automatic differentiation, also known as autograd, by traversing each node and computing the derivative. So, okay, let's take this example too. Grad softmax. Oh, can only compute gradients of expressions that return scalars. Okay. Also be handled. But they also applied it on Tensor, right? I don't know. Let's maybe just for fun, let's sum it. But this is interesting. So now it works. As usual, 30 milliseconds instead of 163 after the automatic compilation. But then, did it actually compute everything? It did. Because it does still return... It still returns tensor, and I don't really get why it returns tensor, because it should... It even said to us that it doesn't compile stuff that is returning tensors. Am I insane? Can only compute gradients that return scalars, got shape, blah, blah, blah. Okay. Can gradient of this expression be a tensor? I'm not sure. Okay, let's not stick too much here, but it is interesting. It's not a computing the derivative. Finally, the computation graph can also be handed to different compilers. As an example, we have implemented built-in for Google's XLA compiler called XLA. We can ask the softmax function to use this new compiler with a module attribute. Well, we just did it here, default compiler. Actually, another thing, of course, is interesting. If we remove that and if we try to restart, it will recompile everything now. I think it should be significantly slower, but let's see. So yeah, it is like 5 times slower, right? That was below 1 millisecond, and now suddenly it is... and this as well. So this is now without XLA, and you can see that it is indeed way slower. If I now re-enable this attribute, it does become faster, I believe. So yeah. Actually, is it still 5? Oh wow, okay. And this became like 3, 2, 4, 5, and here it was... So here, oh yeah, so this was very slow, direct sum, right? And now direct sum is 5. Okay, so it is indeed way faster to use this new compiler with the module attribute. Once softmax is called, we'll invoke XLA to emit a just-in-time and highly specialized compiled version of the code tailored to the tensor type and shape. Passing client CUDA or client ROCm, the code can be compiled for the GPU. For reference, here are some benchmarks of the function above encoded with a tensor of 1 million random floats values on different clients. So that's pretty cool. And keep indicates the tensor was kept on the device instead of being transferred back to Elixir. You can see the benchmark in the bench directory and find some examples in the examples, blah, blah, blah. Before moving forward, it is important for us to take a look at how numerical definitions are compiled. For example, take the softmax function. Define softmax to... one might think that Elixir takes the AST of the softmax AST as abstract syntax tree of the softmax function above and compiles it directly to the GPU. However, that's not the case. Numerical definitions are first compiled to Elixir code that will emit the computation graph, and this computation graph is then compiled to the GPU. The multiple stages look like that. So it starts with Elixir, compiled Elixir version of the code, compiles it to Beam, executes into different AST and compiles to GPU. The multi-stage programming is made possible thanks to Elixir macros. For example, when you see a conditional inside defn, the conditional looks exactly like Elixir conditionals, but it will be compiled to an accelerator if Nx any do else okay. In a nutshell, defn provides us with a subset of Elixir for numerical computations that can be compiled to specific hardware, such as CPU, GPU, and other accelerators. All of this was possible without making changes or forking the language. And while defn is a subset of the language, it is a considerable one. You will find support for mathematical operation, pipes, modular attributes, the access index, Elixir macros, constructs, control flow with conditionals, loops, coming soon, etc. Transformations as an explicit mechanism to invoke Elixir code from a defn. This is, by the way, the cool thing. They already published another blog post explaining how you can use it. And it enables constructs such as grad. And more coming down the road. So, okay. Okay. So we kind of got this short intro. Now let's try to make it compile on the GPU. First, let's see what we will need. See the bench and example. So this is code, but right now the repositories they have, Elixir Nx, it has two things. It has the library itself, Nx library, and it also has Exla, which is this Elixir client for Google X-Ray compiler. So that's the thing I was talking about, Bazel. That's where it needs it. Need Bazel for compiler TensorFlow. So Bazel version 4 is available, but it's not compatible. And that's why I, by the way, needed this Baselisk thing, because on macOS, if you use Homebrew, if you say brew install Bazel, it will install Bazel version 4. Git, Python 3, Microsoft, Visual C, blah, blah, blah. Common installation issues. So to run Exla on the GPU, you need either Rockmo CUDA CUDNN. This combination of CUDA, you need either check the. So let's see if it's compatible with the hardware I wanted to use. So I was thinking of going for this P2 thingy because it's not super expensive, but it does have a GPU, something, and it has NVIDIA GPU. So this is NVIDIA K80. Is it really compatible? I'm not sure. Tesla K80. Most popular GPU. Is it even... I'm not sure it's even compatible then. So... Can you run this? So... And they support 10.1 and higher. So this then won't work. Okay, good that we know. This one is running Tesla V100. Which pairing? I am not sure actually then. Tesla V100 supported. Volta. So that's how. So this is like Volta is called Tesla. What? I'm sorry, I'm so out of the whole GPU thing. And Kepler is called K80. So, oh god, this is confusing. But Kepler supports this. It supports, so okay, I guess we should just try then, run it on this thing. If it doesn't work, well, we won't spend too much money on that anyway, so we can as well try. I don't want to create account. I will be doing some things off the main screen for obvious reasons because of security and stuff. So, but I will try to show you as much as possible because otherwise it will be a tad boring. I am inside my main account. So this is AWS. Let's, I have not done anything with this for so long. I wonder if they have any specific instructions on. So we need to install this CUDA thing. We need to install cuDNN. See the installation instructions. Installing cuDNN on Linux. That was what we were looking for, right? Yes, this is like. Indicated on the page. Okay, so there is like tar file stuff. Then package manager installation. That's always better. I also wonder if Amazon has the stuff already pre-installed. High performance, provides on high BS, machine learning, etc. They don't say anything. I wonder if we can then deep learning base army. CUDA. Okay, that sounds good. Docker for a fully managed experience. But this is, oh, it's even based on Ubuntu, so not on Amazon. Deep learning based army. Let's quickly check it, because then we should have an ability to save a lot of time on installing this stuff. This is Amazon. So with everything you need up until the point of view in such particular, it will have your choice of CUDA versions. Okay. So I'm getting already very confused about all the versions of everything. So we need CUDA above 10.1. We need cuDNN 7 or 8. Okay. So 0.1, cuDNN 7. Has CUDA 10, 10.1 and 10.2. So those are two things. So deep learning army, Ubuntu. So I think that's the one we are looking at. I'm already getting, okay, so that's the launching thing, and here is the thing. 18.4 version 30, latest version 40. Okay, 34. Also, optimized for and they suggest, okay, does it actually say anything about usage? Here, make it a bit larger. below TensorFlow PyTorch includes Kudinen. Okay. Okay. So we can select different CUDAs, which is pretty nice. Okay, I guess we will go in for that one. And then we need to select. So obviously we need to have P2 something. Gosh. So P2, yes. So 461 EBS network P2X large. This is the thing that we want to install. P2X large, yes, it has 1 GPU. Okay, perfect. So do we want to configure instance details? So you have one instance, blah, 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 we don't care. CPU options, shutdown behavior, stop, file system. One thing that I don't understand about it yet is, does it has, it has EBS optimized storage, so it's not, it doesn't have local SSDs, but we don't need them, so it doesn't matter. Shared, okay. We probably need to add some storage, I think. Okay, so it has 60 gigs. I think it's actually sufficient. Delete. It's terminated. Okay. I guess instance EBS. Ooh. I guess it's because I'm in new. I haven't created any instances in Frankfurt yet. Let me better do it off screen so that. So I'm then loading the new key file. Okay, and now we can, now I can put it back on screen and we can launch the instance. Yay. Your instances are now launching. Following instance launches have been initiated. So, looks correct. I wonder what this does. State running, instance type, initializing. So, one thing that I want to quickly configure is to make it to allow access only from my IP. Serials. Thankfully, my IP is dynamic, so I'm not afraid of the unknown right now. Okay. So then, okay, I will also do it off screen. We have the magical address. So I will edit my access. I will try to SSH into it. I will also be doing it off screen because I need to edit my SSH config. So let's call it just GPU, and host name is this thing that I just copied. User, I would imagine it will be Ubuntu, and identity file will be sh. How did I call it? I called it this. So, I wonder if I can already SSH into this thing. Actually, I forgot how I called it because I just called it GPU. Okay. So, yes. So, oh yeah. So what do I need to do? I need to do for GPU key. Okay. To open, I think maybe 400. Will we be in it right now? Yay, we are in. Okay. So there is even magical end user license agreement in PDF file, I guess. And this is a README file, which is pretty cool. Welcome to Ubuntu. So we have those versions available. So this stuff I actually will copy because it is interesting. Is 10. So we will need to update it, right? Just let's put it here and say Amazon E. Just do it like that. I like to keep this stuff just for my future reference. Now we need to switch to, okay, this is the magical link. So we will need to verify our CUDA version. Okay, let's look at what we have on this src thing. CDF tests. Okay, there's like some testing stuff, I guess, and there is also tools directory. GPU CloudWatch monitor. Okay. Okay. Let's go to CUDA 10.2 maybe, I guess. Okay, that was fast. So now, let's see what else we need to do now. So we have CUDA 10.2. Actually, let's even go like the most recent version. Why not? So we just do the same thing. And now And of course, if you listen, it will say 11. Okay. So next thing is we will need Bazel, Python, and Git here. So Bazel, I don't think we have. No, Babel. Git, do we have? We have Git. And Python 3? We have Python 3. Okay, good. So we only need to install Bazel. So install like this. I wonder if Basilisk exists outside of macOS, so it would be nice if it does. So Basilisk. Okay. One-time setup. Okay, let's just do that, I guess. Maybe it's time to create some kind of installation script, right? So that if we will need to repeat those steps, we don't get confused. So install on AWS. And just copy this stuff. Oh man. Let's just select select CUDA 11. What was the steps from here? Okay, so those were the steps. Don't need this, we don't need this. Then install Bazel 3.1 we need. So that has executed, and that, and let's trust it. Stable. Okay, this just adds a list of wrappers. So, oh, okay. Do we actually have Java here? Okay, 1.8 ancient Java, but doesn't matter. What happens then? So yeah, we do apt update, of course. And then we can say is it like 3.10? Bazel versions, I guess. Because I think locally, okay, this is like really ancient version. Interesting, why? Why do they need such an ancient version? Should using version 3.1. I think here I think I have 3.7 here. Gosh, 3.7, yeah. Okay, somehow it worked for me, but let's be good. Let's not minus y. I actually don't remember if that is supposed to go after install. Or yeah, I think I wrote it correctly somehow. So we have Bazel installed, obviously. Now to run check. There's configuration flags. Stop in bash profile. So that we need to add to bash profile. So I for now will just do this like that. Add to bash profile. Does it have bash profile? It has bash rc. Well, same thing. Almost. Custom. So let's also just check that if we go back here and what is extra flags? Okay, that worked. So now we need to install Elixir and everything else here, right? So Elixir. Yep. Okay. Okay. Install. So I guess actually, why would you get minus y, right? Okay. Here we go. So that stuff is now installing, and then we should be able to copy our code, compile it there, and I guess it should already do like GPU magic stuff, kinda. Let's just verify. Exla target. Building this Docker. Well, with Docker, you need to install this NVIDIA Container Toolkit, and Docker is also something that I believe won't be as representative yet. I'm not sure how, if there is. Okay, do we have? Okay, we have Elixir, we have EX, we have Erlang OTP23, we have Elixir 1.11.2. So everything is recent, which is good. And now we can actually, I guess now we can just do this, right? Do I have like one way to copy this stuff is to use rsync. So rsync is a tool I would not recommend normally, but it's really nice. So for quickly experimenting with code, so that's what I will do. I will write another shell script, update shell, which will do the rsync magic. I don't remember syntax. I need to look it up every time because usually it's one thing that you set up once and then you never use it again. So, oh yeah, DigitalOcean articles usually really good. So I'm not sure, do we need like rsync r? It's here, okay. So, progress and partial. Okay. Sync minus R. I guess Z. This is also for me to avoid doing the whole Git dance with that every time. Progress. And there were also this dry run. Dry run. I think you can do dry run also with -n. Yep, -n is also dry run. Source, destination. So for us, it will be then I guess what we want to copy. We want to copy a bunch of files. Source, destination. Include. I think easiest to just exclude stuff then. So we will do exclude. What do we want to exclude? Let's exclude depths because this stuff don't need. And let's exclude Elixir ls. And otherwise, do we want to exclude something else? Lib is okay, test is okay. All this stuff is okay. But let's then make it 3.1, I guess. And, or actually, since it works here, let's keep it, just exclude it for now. So, exclude Bazel version. And then finally, so we want current thing and we want to copy it to GPU and we want to copy it into a folder that we can call Nx test, right? So now I want to give it +x. And if I run, it should dry run things. So it shouldn't really copy anything. Oh, we need to exclude build. That's why you always use dry run thingy before executing anything with rsync. So because build is even excluded from my browser in Visual Studio Code, so I cannot even see that I'm having this thing here. Okay, let's try it again and see. So formatted doesn't matter, update, leap, test. Okay, looks good. So this stuff, I can remove n and actually execute it now. And here you can see I got my Nx test thingy. And I can try to do this. Of course, I don't have depths yet, so let's get them. Shall I install Hex? Yes. Dependency resolution completed. Okay. I guess what I want to do now is to do this, right? First, let's try to compile dependencies and see how it works. You need to have G build this. Oh, yeah. Okay. This is like rookie mistake, right? Let's try again. A is already the newest. You want to install the package. Also install Erlang dev. Okay. Zef. Interesting. Maybe it just doesn't find it. Oops. Compile. I have make. Compile this mix steps compile extra. It cannot find Bazel. I see it now. So it's not about my build essential. It already is on the AMI. It doesn't find Bazel. Why don't you find Bazel? Didn't we install Bazel already? Okay, let's just check it quickly. It's already the newest version. Oh, okay. Fun. 310. I guess. What else can you do? Yay. Okay, we have installed Bazel. Let's do, let's have second screen for that stuff. Maybe I should make it a bit larger because I'm not sure how good it is. Okay. So for the fun of that, let's monitor this as well. So, can we try it again? Make steps compile. I only care about actual prod performance here. Come on, Bazel. Really? Bazel 310. This is like Google style tooling. You want to kill yourself when you use this stuff. Can I make like alias for that? Binary in bash profile. I wonder if I can just do it like bash rc and then like alias Bazel. This is like Bazel 310. So if I do that, yay. Okay. Let's try again. No. Why? It's in a workspace. Okay. Maybe I just need to like re-log in. Do I have this Bazel thing? Okay, it recognizes it. The Nx test. And here, maybe I just need to do like, if I do it without this, no, doesn't matter. That is really, really weird. Do I have actually GCC installed? Okay, I have GCC, I have make, I have Bazel. Bazel is somehow not found. Shut down. What does it try to do? It goes into this scene. XRTS. Can we just go there? Did it clean it up? No. Okay, what does it write in its build file? Not much. Let's try to see this. Okay. It is a bit weird that it suddenly works when I execute it manually. Is it like some... I have Hex installed locally. I have Bazel aliased. I don't get it. I just really hope that it will now work once it's built. Because it does some really crazy stuff. It builds like LLVM, etc. It can take some time for it to build, sadly. But what can we do? Also AWS SDK for some reason. There's also some... Oh, okay. Okay, there is some load happening now. It's always fascinating when you get like more actions discovered during compilation. While this thing does it, let's try to see if we need to do anything else. So you just need to exla flux, exla target. What does exla target do? Bash profile. Tests use exla, which is a dev-only variable for this project. Ah, okay, so exla target doesn't really matter for us, which is good. Now, while it does the magical compilation, let's look at an example they have. So they have regression, and they have MNIST. MNIST is this task of recognizing digits. So it's a famous data set for... Do they actually have an example of how? This will look. I think the examples they took is directly from the book about deep learning. So it's rather famous intro to deep learning and neural nets. So this is like the first example. It's called Neural Networks and deeplearning.com. It's a free online book. You can check it out. If you're interested in the topic, I can recommend it. It's really nicely written. I haven't actually read most of it yet. I only got to the backpropagation algorithmic. But like this data set, MNIST data set, it has those digits, handwritten digits, and it has associations telling you which digit is which. So you can use it for training, for example, different classifiers or neural networks. And here they explain how perceptrons work, how like neural net look like. So you have like input layer, hidden layer, output layer. Show some mass, show how you can implement different logical functions with it. Then they talk about sigmoid neurons. I think in the example here they use sigmoids. Predict Nx logistic. So they take W are weights and B are biases. Those are things that you the defined layer of neural networks. So one layer is one vector of W's and one vector of B's. And next dot in this case is dot multiplication. So if you dot multiply two vectors, you multiply each element by each corresponding element in another vector. And in xadd, pretty much the same thing. It's addition for vectors. And use softmax. This is like forward pass through the neural network. What is actually the definition of this? Look, it's some exponent. So yeah, those like how individual digits look like. This is like, I think they even built exactly the same networks they show here. So you have 784 neurons for each pixel of an image because each image is 28 by 28 pixels. I think, yes, exactly. And then blah, 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 blah. They don't seem to have a hidden layer. I wonder what NX random normal look like. So typically when you build neural nets, you start with random numbers, zeros. I think random numbers are typically better. Distributed random tensor with a given shape. And then, of course, in this case, it then will be 784 rows by 128 columns. Is it so? And then 128 biases. And then, so there is like, okay. I guess there is like input layer. And then you have output layer. And then you have results for like 10 digits. This is like prediction pass. So when you take an input, those 784 pixels, it will return you the result. So I guess, yeah. Then you have accuracy. This is, I guess, only for training and loss. So you want to minimize this loss function. And you have update. This is like one training step, essentially, where you take those parameters, take batch images, batch labels, and step, and then what you do, here they use this auto gradient thing, right? So here is the interesting part, where they take those parameters and they take this loss function and they essentially compute derivative on it logically. And then you get those gradients, and then you apply this formula for updating the weights of neural net. Update with averages, unzip cache or not. Okay, this is just like getting this data set. It will return you zip file. Blah, blah, blah. They parse them somehow. They convert them to arrays, to tensors, as they call them. And here they're training. So they use this update with average function. Train epoch. Yes, train is the entrance function for training things. You get the number of epochs. And then you get the, well, this is just like timing execution of this train epoch function with current parameters, images, and labels. You calculate average loss and average accuracy. You report it and you repeat for the number of epochs. And epoch just uses update with averages that I skipped. and update with averages, calculate loss and accuracy, average load, and then it just updates the stuff and returns additional stuff. So it just keeps track of average loss and average accuracy, I guess. So that's why we have update with averages. It doesn't really change the logic for updating the neural net. It's just pretty cool. So this is like the whole neural network implementation with this NX library, which is pretty nice. Also with like additional helper function for downloading things, and it's like less than 150 lines of code, which is nice. The only thing, we still need to wait for Excel to compile. At least one thing, it's good. It seems to run a bit faster than it was running on my iMac. That was very long time before it compiled. I at least have some time to fetch my water. And by the way, folks, this is live stream, so if you have any questions, feel free to ask in the chat. We need to somehow entertain ourselves while we wait for compilation. Normally, you need to either go for coffee or fight with wooden swords. We have neither, so... So maybe we can also just check the documentation for the... Does it say LLVM project XLA XLA? Yes. Shapes. Yeah. To my shame, I never used Tensorflow, so I just hope that this will work out in the end. This doesn't look really good. See Windows temp. Max Lee asks, thank you first of all for saying that you love my stream. What do I do as my day job? So was this for AI at my company, but seeing how this came out this week, it's early days. Yes, definitely. So at my day job, currently I'm leading a data science team. Well, it's not yet data science team, it's more like data analytics team. Officially, I'm lead data engineer right now. Before that, I was lead software developer. I actually spent way more time doing web development and all kinds of big data processing. Over time, it kind of became its separate specialty, I would say. So it was interesting for me to see how to do it instead of like trying to build a product, trying to do analytics for a company. So that's what I do nowadays. I still very much a software engineer at heart. Yeah, web dev, after some time, it becomes a bit boring, I must admit. It, of course, depends. I think on the front end, it's a bit funnier if you do like different things. On the back end, you always have a database, you have a server, you have an API, and yada, yada. So, but it becomes more interesting if you have like complex logic on the back end. And I did quite a few of interesting projects. For example, one project was for a company that did this like AI-powered analytics, and there you have search interface, it can recognize like natural voice commands, etc. So then it's a bit more interesting web dev. But I definitely find also doing analytics a bit more interesting right now for myself. Still, one thing that I expected when I was a kid is that I would be doing like all kinds of cool algorithms. Of course, that's not how normal development job looks like. Mostly you just do stuff that is, you try to glue things together, you try to compile things, as we can see here. And now answering your second question about Nx. No, I wouldn't try to run a company on something that is pre-release software for sure, and I wouldn't try to run a company with a missing ecosystem, right? So in case of Python, you can use the same thing. You can use XLA to get the same kind of performance, but you also get all other things. You get pandas, you get TensorFlow, you get Keras, you get all kind of tools for machine learning, for plotting things, for reading all kinds of different formats. I think Nx is really, really nice as a starter. It's like, it's something that can enable this ecosystem to also become a thing in Elixir, but it will take, I would imagine, a couple of years at least until you can really try it in production and expect some good results, something that you would not expect at this moment from it. For now, it is a curiosity. I think it's very exciting, but even like looking at this type, you can see that it's not simple. And yeah, typically right now when people have this Jupyter notebook running in your browser a second after you start it, this is of course not an experience that most data scientists are used to. Even if you compile stuff locally, it usually is a bit easier with Python or with even Rust. She's a clone of OTP in Python for pipeline development. Why would you try to copy clone OTP in Python? That sounds interesting, but I think when I think about all the features of OTP and all the features of Python, one big issue would be global interpreter lock, right? How do you overcome that? While directed graphs development. That sounds, wow, that sounds really cool. I think the main issue, of course, with doing anything like that is figuring out the business application, right? Each node is its own process. Directed. Okay, that sounds interesting. I haven't heard about anything like that so far. It is amazing how many ideas are out there. I'm starting to think that try and Docker may have been a good idea. Let's try, while this scene runs, try to run this example locally maybe, so that we do something without just waiting for the thing. So that's the example. I will just put it in the module. MNIST EX. So first off, let's see if it will compile. Okay, we got a bunch of warnings. Does not directly bend. CF application. So we got a bunch of warnings right from the start. I guess this is because okay, I really hope it will not take us 3 days. I don't want to spend this amount of money on trying this thing. I think on my iMac, it's also, by the way, it's not the whole TensorFlow, right? It's XLA thingy. So I think on my Mac, it took me about an hour to compile it. I think on this machine, it should run a bit faster. It doesn't have, it has only 2 cores, apparently, but 4 cores, but still, we will see. It is doing something at least. It is already way better than before. And yeah, I guess ARM I think nowadays it should be better with ARM. I even read some articles that they have done special magic accelerating it for M1. I'm really looking forward to also try new Apple Silicon stuff. Okay, let's try to see. Okay, we can recompile this stuff, and then we have this thing for, I guess, let's call it runner ex. And here we can just do diff module runner do. I guess alias. No, I don't want to do that. Let's do that. I wonder where it probably will end up somewhere here, right? Woo! Okay, it likes to output stuff, that we know now. But it did download something somewhere. But where? So images, unzip cache, or download. So file exists, unzip from temp, start response file encoder. Oh my god, it's here. Okay. Let's do if file exists temp. By the way, what does this in return? True. So let's do it like that. By the way, this is absolutely not correct Elixir, right? I need to do a function from this stuff, but how do we call it? Let's call it run. Not the most exciting thing, but yeah, it has downloaded to this TMP thing. So actually, when I think about it, it also returns the stuff. Can I? Oh well, I will be really bad person, but I will do it like that because don't want to waste too much time trying to change it. So it already has this kind of logic. Okay, that's good. Then I don't even need to do it myself. Okay, initializing parameters. Let's wrap it up into timer TC thing. Well, it's not super good yet, but actually I probably should do it properly like that. And then I'll get time and I will get params, right? And I can also just do it like that. Same thing, so we can run it. Now time is this, but this was the first thing. If you do it again, so wow, that's fast. I want to write it down for comparison, and I want to run it a couple of times just to see how fast it will go. Oh wow, okay, so 19, 17, one more. Now suddenly 10. Okay, interesting. Then we need to train it. So here then, let's also do the same thing. Take this and this. And then this will be like that, right? Take train function and take this. I think it should work, but maybe not. We will see. I don't want to spend too much time, so first let's train it for one epoch, and then we will see final params. And then we will do that as well. So now, Yep, we will need to wrap it into another list so it understands that those are keyword arguments. Okay, that took quite some time before JIT, right? And now if try to do the same but with JIT. Oh wow, it's still quite slow. To JIT. So let's try it several times. Okay. I wonder what this does. Backend transfer. Transfer data to the given backend. They shall pick the most appropriate backend. I don't understand this. Accepted tuple. Okay, I guess. I want to just... Whoa. Okay, just prints stuff, I would imagine. I wonder if we can actually classify anything with that. So we train things. Yeah, the thing is, this one doesn't even run on GPU yet, right? We are on Mac and ROCm only works on Linux. So this is like CPU backend. That's why we actually compiling stuff on Linux, because this is an instance with GPU, and if it compiles, it should be able, and it's also with CUDA, so it should be able to run then on GPU, and then we can compare. And that's why I wanted to also check it. Of course, this is like apples to oranges, because I also have different processor, and my computer is like ages old. It's like 2017 iMac, but still. Let's see if we can use those final parameters to actually do something. I also wonder what we actually got here. So we got those train images. I would imagine they're probably in some weird format, right? So let's go there and try to do that. Train images. Images. Is it even a directory? No, this is like... Okay. Okay. So this is like just binary array of those things, I guess. Also, I wonder, did it print anything? So let's now try to do it for 10 epochs and see. So at least, okay, even if we don't get easily to see how it classifies stuff, etc., we can at least see that we should see average accuracy improve and average loss to go down. And that seems to be the case. So after one epoch, you can see that accuracy is 79.5%. And in the 10th epoch, it's 93.5 almost. So that's quite good. Yeah, it's 6.5 things there. So we can as well take a look at how this data set is structured. They are downloading it from here. So what the hell is this? Open images. For me, it's interesting if we can at least look at the images themselves. So okay. But they don't talk anything about MNIST. Does it like okay? I am becoming more and more confused. He has a function to show images. Okay, this is interesting. Actually, by the way, I still haven't seen the demo. I was just playing with the code so far. I probably should do that. I don't see anything like that here. Download he has, and train batches, and train. I see. Я не особо планирую делать ничего на русском. Мне кажется, что на русском уже есть свои IT-каналы. Мой на английском, sorry about that, но кажется, что это будет еще хороший повод выучить английский, нет? So yeah, returning back to English, we don't have any code for showing the stuff here, but we can look at have examples here, which is just this stuff. Maybe in Nx they have something useful. I don't think so. Shape, chart, tensor, type. Okay. We don't have a function to show in images, but that's not a big deal for me, to be honest, because the main thing, I just want to see how fast it will run on GPU. That's kind of the only thing I'm interested at this point, compared to running it locally. To next race. Okay. Actually, I think about one thing. I think if it is an X array, they have this function. They have heat map, I think. Yeah, I think I need to do like. By the way, is it? Yes. Heat map? No. To heat map. So maybe that's what they use to actually show the images. Yeah, I wonder. So they download this stuff and they write the data, and then they download stuff, train from binary, take images, they just shape them, and okay, I guess we can just try this, right? Let's import MNIST thingy, unzip cache or download. Why this function is, oh yeah, because I'm not passing images correctly, right? Let's try to do something like show, maybe. And let's just like, okay, if you take this, if I execute it again, okay, it's using that from cache, so that's good. But now it will recreate the vectors. Okay. And it prints them, and then we get to train images. Did we? Okay, this is one little issue that will make it hard to work with in real life. I guess each of those is batch 30 input 700. Okay, I guess we can just take like image, which will be like first of those. I don't know, will it work like that? Nx. if you're trying to pass the link, I think it will not work in the chat, because usually that's the problem with YouTube. If you allow pasting links anywhere, you will get a lot of links to spam. So that's why they're disabled by default. But you can write it not as a link, just like in different parts. I wonder if they have like a function. By the way, what is happening now? Okay, we are at 7,000. I really hope that we won't get further away from that. And by the way, this is... Okay, I'm just doing Bazel build, right? Mean map. I'm thinking how... Okay, it's not a problem. You can write in Russian. I will just translate it when I read the question anyways. So what will be better, Go or Rust? Rust has more potential, but there is not much positions for it. Will it be the case that there will be more open positions on Rust in 3 years? Well, I definitely hope so, but I am very biased, right? It's like, in 3 years, what will happen? I believe that both Rust and Go will be very popular languages. It's just a question, like, Google is pushing strongly for Go, and people who want to work in Google, they learn Go, and people who are taught using Google materials are taught to use Go. At the same time, Go is a language that most people, okay, I wouldn't say most people don't enjoy, but it is a language that a lot of people don't enjoy or don't find sophisticated enough. Sure, cheers to you too. But at the same time, I do believe strongly that Rust is a better language. It got a lot of features that Go only plans to eventually implement, and it is more fun to work with. It doesn't have garbage collector, so in the end, if you really want to go as fast as possible, Rust is not comparable to Go. Rust can go way faster. So I think in the end, you will see way more positions for us, definitely, if we talk about like low level or high performance or something like that. But Go will be the language a lot of people will be using in the situations where Python is too slow, but something like Rust is not yet required. So like medium to high load websites, for example, I think that's a good niche for Go. But it's also hard to predict what will happen in 3 years. I think both languages in 3 years will develop way further and probably will also be a bit closer to each other, right? So Go will add generics. I think they still haven't got them, but correct me if I'm wrong, because I have not. Thank you. I think maybe it's also because I'm Russian. That's why my English is a bit easier to parse for other Russian people, because I have accent. But apart from that, I think Go in 3 years will be quite similar to Rust in sense that it will have generics, it will have some features like, I don't know, better functional programming, etc. So in the terms of how the language is, how you feel the language when you work with that, it will be closer. And Rust probably will get faster compiler. It will be also a bit easier to work with. Maybe there will be like some kind of extensions that allows you to switch to garbage collected mode if you don't really need the whole speed. I think the choice will be a bit less intense between two languages, you know, but we will see. I'm really hoping that Rust will become larger, and so far it is growing quite fast comparing to how it looked even 3 years ago. It was like very, very niche thing. There were no positions at all anywhere. I was really looking and trying to find some place where I can use it, and there were literally nothing. Right now, at least in Berlin, we have quite a bit of options. I believe in Moscow, you can also find some positions in Rust. In St. Petersburg, a bit harder. Of course, in the United States, as usual, it's the easiest. You can find a lot of positions. But yeah, if you want to live in the United States right now, that's another question, of course. Yeah, we are at almost 8K. We need to survive a bit longer while this stuff is compiling. I will try to do this again. I really wonder if there is some way to prevent EX from printing all the stuff. I never actually saw something like that. I think it's not a typical feature for a function language to have because you normally don't have arrays and stuff. So you don't have the problem. I guess we will need to do it again. Yikes, it will print a lot of stuff now. Interesting thing is that it doesn't, it doesn't have like grayscale or anything. It's just like if there is a pixel or there is no pixel, it's like 0 and 1. So train, okay, let's just try to do stuff with that thing. I don't know, okay, there are 2000 training images. That's what we know now. Can we... maybe we can try to do enum add on that thing. Will it work? Okay, so we got an image. This is good. It is interesting that it is, for some reason it uses floats, though there are only zeros here. I wonder now, I don't know. Maybe this is like bounding box or something? Of course, that should fail, by the way. Will it? Yeah, nil. Okay. But then, if you look at the image, and if we try to do an X2 heat map image, it should be a tensor. Oh, yeah, I should, of course, do that first. Dump. So now we have a tensor. Yay! Something is happening. I'm not sure if that's how it's supposed to look. So it's not 2000 images. This looks to me like compressed something. Okay. How many? So this image, can I get like some size? Yes. Maybe, I don't know, dimensions? No. Okay, that's the moment where we look at documentation, I guess. So, okay. One thing that I'm still trying to get used to is always opening documentation in another tab. Actually, I wouldn't even find documentation here yet, right? It's not yet published to Hex. So I guess we will need to generate it. I think you can do like mixed docs. I think we will probably need to install this dependency. So it's xdoc that we need, and gosh. Okay, I found the version. Let's just install it here. It will be xdoc. One bad thing, I think recompile is broken now, right? If you change... no, it's not. It will not find xdocs yet, but at least we can compile stuff with that, and then we can look at documentation. I everything is compiled now. Okay, we got something here that we hopefully can see. Search runner build. I wonder actually if I can open. Does it know how to do like a show maybe? Help docs. So nesting, blah blah blah. Not interested. Mix docs. Language format canonical. Okay. That should print all commands that it has. Okay. Well, we tried. We will open it like that. Oh, and I think this is also. Oh no. Okay. Doc index HTML. Can we actually do it for like dependencies and stuff? Project, because that's my stuff. If I go to dependencies and if I go to, I can go to Zaps and to Nx first, and then okay, mix docs. Okay, let's try another documentation thing. Okay, and now I can do open doc index HTML. So this is documentation for Nx. And here, so we have broadcasting. Okay, access syntax and slicing. So that's the point I wanted to see. So we can use this. Negative indices are elements from the back. I will make it a bit larger. Access also accepts ranges. Ranges in Elixir are inclusive. Okay. Let's see. Okay, so you essentially can like index it like that, and ls2 very nicely with name tensors. Okay, that is all nice. Since we are doing that, let's also look at Exla and try to do the documentation here. Okay. Wow, okay, we don't get documentation here, obviously. But at least it only talks about clients. Oh, that's actually interesting thing because that's what will allow us to switch, I guess. Singleton resources. You configure a client via the application, for example, configure default platform host, platform CUDA. Okay. So then, I guess, it's one annoying thing that it doesn't generate config before, config automatically anymore. It was such a nice feature because you almost always need it, but okay. Config access, so import config, right? Yep, and then we can. So I think right now it will change nothing, but we can then also configure this stuff. For the future. Okay. I will go back to my main directory here. So we learned that we can look at those images like that. I'm now thinking about one other thing I wanted to check is the size of the tensor, right? So bitwise concatenate docked logical or rank sign size. I guess they call it shape, right? Yes. Oh my god. Okay. So we can do an X shape from image. Okay. So we got like 30 by 300. So we got 30 images. Each of those images is 784 pixels. So if I then say image, let's try to do it like that. So I say image 0 and I pass it. First of all, okay. And I can pass it to NX shape. And we got those things. Let's try to maybe to broadcast it to it was, I think it was 28 by 28. Yes. So 28 by 28 with access 1. Let's see. Maybe. How to split it into rows of 28 elements and multiply. Tensor. Something like reshape, maybe? Yeah. Changes the shape of tensor. New shape is either a tuple. Okay, so instead of broadcast, we need to use reshape. And now I guess we can do heatmap to heatmap, right? Yeah, okay, we got the number. This is pretty cool. So then let's just go for like first. I actually forgot how this works. So, oh, okay, good. So this will allow us to show, actually, I don't care. Oh no, this is index, so This will allow us to print those images, right? So, okay, at least we can recognize them ourselves. Now, if we can show an image, can we also make it train labels? What is train labels? Train labels is also, can we maybe look at them together? So if I say train labels and I ask for the first one, it will give me this. And then I can ask for its shape, and it's 30 by 10. And this is 30 by, so okay, so we got 30 images in each batch, right? And in those, and we got 30 train labels. So we can actually do this. Let's just do it like that, I guess. Label. And here we can print the label, which will be done train labels in at train labels, right? And then labels. Okay, I see. So since we need to essentially, we convert, instead of returning a number from 0 to 10, we return a vector where one of elements is 1. And in this case, the element that is 1 is, so 0, 1, 2, 3, 4, 5. So the number should be 5, right? And if you look at image 0, do the magic with reshaping and stuff, it should return 5. It's 5. If you look at this one, this is 0. So this image should be also 0. Yay! Okay. Labels. I guess then if I say labels 0, if I look at that, I need to return a num find not implemented. Maybe we have something like Nx find. Type tensor sum share random power mean dot argmax. Maybe argmax will work in this case. Yeah, so we can then do an x argmax. It should return an index of the largest value, which is in this case 5. Okay, splendid. Label is equal to labels I label, and this is heat map. I wonder actually what this function will return. It will return this Nx heat map thing. I guess for now we can just do it like that, right? Probably shouldn't. Oops. Okay, let's just do it a bit faster. Let's only return first 5. So now this is called show, right? Runner show. takes quite a bit of time to decompress it into those. Not implemented. Yeah. So label 0 Nx argmax. I think Nx like that maybe. Iota. I guess it's not it's iota. Then I guess inspect. Or maybe even L0. Scalar tensor. Can't use. How do you extract value from a scalar tensor then? Done access. Outer. Maybe if I can use like no. Slice, subtract, squeeze. To batched list. Converts the line tensor to a list of tensors. Okay, they use it to flat list. Tensor underline tensor as a flat list. Oh, so that's how it works, I guess. To scalar. Yay. Okay. So then we can take this and we then do to scalar. And we got 5. Okay. This is the thing we are missing here. To scalar. Right? Let's recompile. And then we can try to run it again. It will take a lot of time to use this stuff. But then, okay, it prints it. We got, okay, it printed it in the end, but 50419, 50419. Okay, it matches. Okay, at least we understood how the data is associated with each other, right? We still need to wait a bit for the stuff to compile, but we are getting closer to that. Now, in the remaining time, let's try to also make it predict stuff for us. So what is this thing? So final parameters. Did we get it? Let's extract it. And I think we can also we can save some time by instead of printing this stuff and like running this stuff every time, what we can do, we can save the results in final parameters just as a binary, because thankfully in Elixir and Erlang, everything is very easy to serialize. So, yep, got that. And then we get this. And this will run for some time on my CPU. So what I'm trying to do, this code supposed to train neural network, right? To recognize those handwritten digits, and from those images, it should infer those labels for them. The thing is, we have the code for training things. So this train function actually does all the logic, like it runs multiple training steps. Calling this function called train epoch, that calls this function update with averages, that calls this update, which is essentially a neural network training function. It uses this auto differentiation stuff from an Nx library and all the vector multiplication, etc., to make it faster. Now the question is, when we have this, we have the training thing. It returns us this final parameters thing, which I would imagine is a tensor. But we cannot yet recognize anything, right? We just got some numbers there. So what I'm thinking, how do we actually recognize things? It has a function which is called predict. It takes this patch, and I would imagine that maybe this patch is the final parameters, but I'm not sure. So I'm trying to establish that actually. I think we can. Okay, I think it should have finished training things. Yes. So in the end, let's look at the final parameter stuff. We got. Okay, so those are parameters. Those are weights and biases for the first layer, and those are for the output layer. So then, okay. I'm dumb. So that's what we got from the final parameters thing. Let's add one simple thing. Let's do Erlang. Can we actually do that? Binary. I think it won't work. I think with Nx, this stuff won't work, right? But at least, I don't think we actually need this. I think we just need final parameters. Let's do it like that. And then we can do predict. So where we take final parameters and we take an image. Actually, better to do it like that, so we can pipe into it. Take an image, and it always takes a batch of images. Next dot. I wonder if it will work with our converted images. I guess. No, image I still have here, right? I don't have it yet predicted. Okay. So we can take final parameters here, and then we can call this. Okay, you know what? Compute. Let's call it like that. It should return this stuff. So you can then take this. We still have train shape, train images, right? It's just, I would imagine this is just train images. This is just the list, yes, and train labels. Okay. And then let's try to compute stuff with this. So if we have train images, we have image, which is a batch of 30 images. And then we can try to call MNIST, predict final parameters and image. Excel device backend. Is it final parameters? Okay, because it moved it there on the backend. So we need to actually, okay, I want to see the actual vector. I don't want to move it to the backend. I want to just see what it returns. Let's then do this thing again. But why? It is a bit weird. Okay. That's why. Because we have this run options keep on device, I guess. So you know what? No, we won't keep it on device. I want to actually see what is happening. So let's do it like that. We will need to restart, I think. You will need sadly to rerun everything because I don't believe you can just save it with Erlang's term to binary because those are not Erlang terms. I'm not sure. Let's do the training thing, and this time I hope we will actually see the tensors it outputs, so like the parameters for neural network. Okay, so now final params are this stuff. So this is like weights for the first layer, biases for the first layer. And those are weights and biases for the output layer, where we will get actual answer from. Now, we can try to run the predict thing. So we have MNIST. Oh yeah, and we also need to do this. So we take images, label. So we got first, this is first batch of images. We can get like image, first image from it. Is this, it's 5. And now we can try to do this. So MNIST find predict final params. And we pass in the whole batch here because it says batch. So I would imagine that will be the whole thing. Okay. I guess then we got what is the shape of this thing? 30 by 10. Okay, so each one, let's take the predictions, I guess. I will just, I don't know, I will put it into a document. So we got predictions. Let's look at predictions. 0. Let's maybe take argmax is 5. So we got our prediction 0, 1, 2, 3, 4, 5. Indeed, here's 5 actually. No, I'm dumb. 0, 8. And those are all with like E minus 6, etc. So way less. It's pretty cool because it also is probabilistic thing, right? It shows us that kind of like probability of which digit it is. We can also look at prediction for this. It predicts 0, and for the next it predicts 4. And for the next it predicts 1, and then 9. And that's exactly what we saw in images, right? Now, this is absolutely like one important thing to say here. This is not how you do machine learning. I'm sure that this is training set. And of course, if you check stuff on the training set, you kind of trained your neural network to recognize exactly the stuff. It won't generalize. So normally, I wonder actually if it is splitting it to like training and validation set and testing. I don't think it does. I think it just takes the whole thing and it trains on it. Images. Yeah, looks like it. So and train epoch, it also... Yeah, it takes all images. Maybe they can split it. So, okay, we got the first batch only. I'm thinking train images. And here, I guess we got like 10 things. Maybe if I can limit it to only like first several ones and then use the last one to do actual honest prediction. 2000 batches. Okay. So then I can do it like that, right? I can say take those. Yikes. Just to be completely sure, I can do it like that. I can say training set. No, not a board chain. Okay. Terrible mistake. Okay. Let's take this subset of this and then try to rerun training only on those so that we at least are consistent. I also think training set labels, I guess, right? I actually wonder if train labels also a list. Okay, and length of train labels is 2000 as well, so we can take exactly the same amount of them. And now we can use it here, training set labels. So let's do honest machine learning. Let's train it without the whole data and just pass the remaining, like take last batch and test on it so we're sure that it has not seen it before. It's also new numbers. Okay, we got our final parameters. And by the way, what is our time? It's like, yeah, 1/6. And here, instead of doing that, let's take the last one, right? And let's do predictions. Actually, if we're doing predictions, let's try to do it properly. Let's try to do it with... So I want to do like an X map and like tensor... Actually, X pro... No, argmax, right? So I want to do something like that, I guess. Did it work? I did something weird, I guess. 0, 0, 0. Because it maps, can only map like through one dimension or something. Oh man, it feels like it's becoming slower the longer it runs. But this is like not burst instance, so it should not become slower. Okay, we only need to wait for 2k more things to compile. For, oops. Tensor. Adoption. I just want to go through one dimension. Can it go through one dimension only? Multiply, outer, power, reshape, reverse, slice? No. Squeeze. I guess broadcast maybe can have some options to do that. First matches. Okay. Must match. Okay. The axis to aggregate on. If no axis is going to return the index of the absolute maximum value in the tensor. So I can try to then do it like this, right? So those like Nx argmax predictions. Is it axis or axis? Axis, okay. Axis 0, I think. Not sure. Batch 30, output 10. Or if I do like that. Ooh, okay. Let's see an X. I always get so confused between those rows and columns. Which one is which? Predictions is 30 by 10. So 30 rows, 10 columns. We need to get certain numbers. So this is a correct thing then. Because otherwise we will only have 10. Yeah, and those are also correct numbers because they're between 0 and 10. Okay, makes sense. So then this is the command. And then we can also just convert it to list. So to flat list, I guess. Will it be what I expect it to be? Yes, okay. And then let's just do that, I guess. So 2, 2, 0, what is it? 9, 2, I guess. Oh man, I never lived in Czech Republic. I have no clue. I think, like, which language do you prefer to learn? German or Czech? Choose your poison. I think that will be the main deciding factor. Another thing, of course, salaries. Salaries in Germany are slightly higher, but not like super high. It's not United States. You will not be super rich. Here, by doing programming, you will be just like okay. Otherwise, I think more companies definitely are in Berlin and in Munich than in Czech Republic. But Czech Republic actually has a lot of like outsourcing things. So I don't think that's that good, honestly. Depends. But yeah. I personally chose Germany. Until recent events, I have not regretted it, but sadly we are 4 months of lockdown now, so that's a bit sad. In Czech Republic, though, it's not better. Yeah. Otherwise, I think it really is a matter of taste. I would suggest if you want to move, visit both countries, see where you feel more comfortable, and then just move there. Prague is the most beautiful city on earth, I believe, so that's also an important factor. But yeah, so we got the numbers, right? We got the... This is exactly what I read, so the last one is indeed 2. Let's look at our predictions. If the neural network works, the first numbers should match those numbers, right? So we execute it and we get 22092. 4. No. We got 22094. Okay, this is interesting. Can we, like, if I look at that, let's take the, this is, I think, fourth element should be, okay, let's do an Nx argmax 9. So, and the next one then is last one, right? 4. Okay, so we can see that it really predicts stuff. It is not always correct. For the last number, the official label was 2. For me, it was also hard to read it. I was not sure if it's 2 or 9 or 6 or whatever. And it predicted 4. But otherwise, it was correct, which is pretty nice. Okay, we are almost there. We need to wait still for 1.8K of things to compile. And I hope that after that we can run it. If not, I will wrap up for today because it was almost, I think, 2.5 hours now. Wow. So, and I think first half an hour I was talking, or first an hour. So it was compiled for more than an hour now, which is fun. But let's hope that it will eventually finish. Can we look at some other numbers? And let's look at the next thing. So let's go from 5 to 10 maybe. Just do it like that. And labels, this is 4. I would not have parsed it myself, I must admit. This is 6, 7 or 1? 7, okay. 3, 1, 3. And if we again look at our predictions, so 4, 6, 7, 3, 1, 3, right? 4, 6, 7, 3, 1, 3. So yeah, it made like this mistake with this 2 in the previous batch, but then it's again correct. It's quite impressive stuff. It really works, and we have verified that it works. Let's look through the docs while we continue to wait for the compilation on the Amazon instance to finish. I wonder actually why it has a bunch of methods that look to me like enum, but I think, does it implement enum actually? I don't think it does. Generic container. Access data name T type. Aha. Shape. Okay, so it just kind of has this meta information for this. We can look at the code itself as well here. Yeah, sorry, Mark. I don't plan to do anything in Russian because I think, like, why there is no content in Russian, because Rust is just not that popular yet. I think it's important to have at least something about it in English as well. For me, since I'm doing mostly really rare things, so I'm doing Elixir and Rust so far. I also plan to add Julia this year to my roster of languages. Neither of them is very popular, and I think it is important that as many people as possible have access to that. So that's why I'm doing it in English. Sorry. As I said before, it's a good point to also train your English. So let's look what they actually do inside it. Since we have so much time with compilation, we have verified that neural network works. Let's see how this stuff is written. Oh, it does implement access behavior at least. So it defines a struct, and there is an access thing which uses fetch access. Fetch access. Impl. So that's how. Big struct. Okay. Let's see what happens when we create a tensor. So def. So creation API. build a tensor. Those all docs. You know, Mark, regarding learning languages, really, this is the most important skill you can possibly have. Like, I think if I could choose between forgetting all the programming stuff that I know and forgetting English, I would rather forget all programming, honestly. Because apart from just like professional stuff and like finding a job, etc., it also is about being able to communicate with people from across the world. And I think that is such a, it's such an important thing. I was, so like I am doing edited videos right now regarding subtitles in Russian. I'm doing edited videos right now for graphs in Rust. I definitely want to add subtitles in Russian there because it's kind of easy, you know, they're only like about 10 to 15 minutes. I want to stay about in that time frame. So I will try to add subtitles. Plus, by the way, sometimes YouTube subtitles in, it does work okayish. Not always. Sometimes it just outputs complete nonsense, but sometimes it works. So depending on how lucky you are. But I will try to add subtitles definitely because it's easier. For my streams, for like 2 to 3 to 4 hours things, it will be that tough to add subtitles. I don't think it makes much sense, but for edited videos, I will try to add them, definitely. Flatten. Okay. So essentially, they always call this simple thing to create a tensor. And this thing to struct. I don't get how it actually works. Maybe there is some kind of magic happens. Okay, let's see where we are. Okay, we are almost there. It's now 1.5K. We're getting close. Eventually, I hope we will be able to run something. Okay, nothing is here, but let's maybe look at sources there. Inspect color. I think they're using this inspect thing. So you can, by the way, it's really cool feature of Elixir. You can override any kind of inspect things. So like pretty printing for your structs. And here it using also IO ANSI module, which prints stuff with different colors. So that's how this shows a heat map. That I also then wonder what happens. Okay, this is dump. Looks funny. It really prints it's like this fake struct like syntax, but with this stuff. By the way, Fox, regarding Rust as well, I will try to publish a second video about graphs with Rust upcoming week, latest week after the upcoming week, because this one will be about how to represent any graph in Rust. It's kind of funny because normally graphs are not as interesting, like representation is not such an interesting thing, but in Rust with the ownership stuff, it kind of becomes interesting. And I will do a short review of possible approaches. So that is coming soon, I hope. Mark writes that he is doing data engineering right now. Mark, if not a secret, which company was this position from? I really wonder. Yeah, you can I think you can definitely do a HDFS in Rust. I think it's not a big deal. I think it has a library for that. It definitely has support for Parquet. There is Rust Arrow library, so like all the Arrow Parquet stuff it can do. Green Bank. Okay, okay. Yeah, but it's interesting that they were looking for data engineers with Rust. It is like at my company, we were hiring. We thankfully closed all vacancies now, but we were hiring data engineers, and Rust knowledge was plus because we used Rust for ingestion and for speeding up some things. It's interesting that we are not the only ones because it is quite a rare thing. Like data engineering is rather rare thing nowadays still. Plus with Rust, it's also not something so common yet. So pretty cool that they're also using that. Okay, yeah, almost there. 4 actions running. So it compiled. Oh my god! It didn't only compile XLA. It really compiles whole TensorFlow. This is so weird. We didn't get much info from there, but let's look maybe then more on the compiler thing. Backend. So that's, I guess, how they implement the representation of the tensors. Limitations. Opaque. Oh, Nx binary backend. This is the default backend. The backend it's provided must not be accessed directly. Okay, this is pretty cool. And Jeff, public is the built expression graphs that are traversed by custom compilers. Regarding Scala, well, I have written it for 6 years. Scala was the language with which I got my first job in Germany, so it kinda got me the blue card and allowed me to move. I don't think it's a language that will become more popular. I think it's becoming less popular over time. So that's kind of the thing, right? If you don't know it yet, I would not recommend learning it because you probably will have fewer options to find a job. And of course, GVM is such a pain in the ass, but what can you do? It's still a very popular thing. You still can easily find vacancies for Scala here as well in Berlin, I believe in Czech Republic too, in most European countries, I think. But it is a language that is really weird. It has a bunch of concepts that I think it kind of, I think the main contribution of Scala is the proof that you don't need to do something like Scala. Like it's fine to have OOP, it's fine to have functional programming, but like mixing them together doesn't give you much happiness or much additional power. So from the point of view of a scientific experiment, it was very successful because we learned things. From the point of view of an industrial programming language, not so much. Rust definitely has more potential. But so is, by the way, Elixir. I think there are way more vacancies for Elixir here in Germany than there are for Rust, which is pretty fascinating. But this is kind of local phenomenon. I think there are also a lot of people who still write Ruby here, which is also like nowadays it's becoming harder to find Ruby vacancies otherwise. But here we are, hipster paradise. Let's look at the backend stuff then, I guess. Oh, so you need to implement all of that. Really? You need to callbacks defined in this module. So you need to implement this stuff to main of which is stanza, which actually I guess creates this stuff. But it's also like, look, this is interesting stuff. Like you even need to do like the decomposition stuff. You need to re-implement for each backend. This is an interesting approach. Okay. Binary backend. Tensor ST. So it essentially just does nothing, right? I think. Yeah, Rust content is definitely coming next week as well. Like even if I will not finish my video about graphs, I will do another stream with Rust. Not sure about what yet. Maybe also something like ecosystem highlights. I really like the one about Zola, sorry, because it was not it's kind of, I didn't do much Rust programming there, but it was still cool to see what is possible to do with the language. And I think it's also kind of a bit more interesting to try to apply some stuff. I try to do those series of streams where I try to write an app, but then I just got bored after some time because it's like being on a second day job. You just develop the same thing over a longer period of time. And here I mostly want to try multiple things, not spending so much time on any one of them, really. Just exploring stuff and seeing how it works and learning new things. So doing something like that will be funnier, I think. And by the way, if you want to see more content about Rust, I have a lot of streams. I did the whole advent of code in Rust in 2020. So there are a lot of streams with that. You can see me solving stuff in real time, all those puzzles. There are also videos about, it's called Audio Adventures in Rust, where really it's more like trying to build a desktop UI with Rust using web technologies, which was pretty fun, and also like integrating with Spotify, etc. So I have quite a bit of stuff already that you can check out. And more stuff is definitely coming. Oh my god, we need to wait for 1K more. I think I need more water. Thankfully, I still have some, so. Okay, but those are all pre-built, so I guess there is no way to speed it up when you set it up on a new device. So, yikes. Well, one thing that exists, you can kind of run this Bazel thing as a server, and then it caches stuff, and then you can just fetch this stuff from a network, I guess. So that's kind of a solution, but yikes. It's not super easy to experiment with it so far if you need to wait so long for each new machine to install something on. I guess, folks, I will be running away. I guess we won't be waiting for it to finish compiling because even though it looks like it's only 300, I think it's becoming significantly slower and slower. I will run it till it finishes compiling, and then I will probably do a follow-up video. I will just save the image that is on this virtual machine, so hopefully we will not need to recompile it again from scratch. But I'm not optimistic that it will finish in any time soon, and I'm super tired already, so it's better to wrap up for today. Thank you so far for watching. I hope next time we will have more fun with compiling and running it on GPU. In any case, it was fun. We looked through it. We were able to verify that it does work as a neural network. And even without GPU stuff, it still worked sufficiently fast on my machine. It's a bit tough to compare it with performance it would have had without the compiler, but who knows. Thank you so much. Don't forget to like and subscribe. We will do a follow-up where we will hopefully look at how it really works on GPU, and if it does, speed things up. I'm quite excited about this project. I hope the experience of installing and using it will improve in the future, but for now, it's a big step forward for the whole Elixir ecosystem, and yeah, let's have more fun with that. Thank you. Bye.